Hello and welcome to the last video of session 3, Python files. Now earlier in the handout I showed you a number of structures. If we look at the actual name of the session, it's called Lists, Tuples, Sets, Dictionaries, and Files. Now all of these are containers except for a file, which strictly speaking isn't a container. We're including it partly because it's so useful now to be able to open up a data source and pull data out to use in our container structures. That it's important that we learn it now anyway. But the other reason we talk about files is because you can actually use files as if they were sequences in some ways, not in a lot of ways, but in some ways. What we can do, in fact, we should probably set up our own text file to work with. Why don't we just create a text file right now? And it's something that I would certainly recommend that you do. Test.txt if you just want to play around. I'm going to create a file of words. Hello there, this is David. I just wanted to say that I am so excited that you're learning something new and that I am partly responsible. That's right, folks. I'm actually quite excited about teaching you things. Just the kind of guy I am. Let's make sure that that worked. Okay, good. Now, let's open up the file and read it. Now, as with any situation in which you're asking the operating system to access a file, and anytime we're looking for a file at all from within our program, we're asking the operating system. I don't know if you know, Windows used to be called DOS, and DOS stands for Disk Operating System. It runs the disk, right? It does a lot more than that, of course, but its major occupation is being able to store and retrieve information on some sort of storage, in this case, a disk. And so anytime we want to open up a file, we have to ask the operating system for it. The operating system is going to check the file system for the file that we ask for. But of course, the operating system is not going to check everywhere in the file system for a file. And in fact, we could have files that are named the same in different locations. So usually the operating system will look in their current working directory or the present working directory where we're sitting, that is where our script is sitting. If we want it to look elsewhere, we can feed it an entire path that lets it know exactly where the file is. But if we don't feed it a path and we just say open a file, Python's going to tell the operating system to open the file, and the operating system is going to simply look in the current directory to find it. And since it is in the same directory as where we're working, it will work. Well, we get back from a call to open, where open takes the argument, which is a string, the string being the name of the file that we want to access. It returns something called a file handle. We're naming it file handle. We could call it f handle. We could call it handle. We could call it fh, whatever we'd like to call it. It represents the file. It's actually an object that represents the file. Why don't we print the type and see what Python calls that object. I call it a file handle. That's not necessarily the right one. Type file. Okay, so it's a file object, the fh. Now what we do with this is we can loop through it. So I can say for I and fh, print I. In fact, why don't I just say file line in fh, print file line. I like those descriptive titles because they make everything nice and clear. If we clear this out and run it again, you get back the entire file. You can see that the file here is entirely represented in the program output. And that's because when we loop through a file handle, the file handle simply delivers each of the lines in turn until it's done. When it reaches the end of the file, it stops and the loop ends. And then Python can continue on, or it can exit as it's doing here. We could go ahead and show that this is the case. It runs it through, prints all the lines in the file, and then prints done at the end. But why are there extra lines here? I see an extra blank line for every line in the file. If we go ahead and list out the file again, you can see it doesn't have these blank lines. But when we run Python, it does seem to have these blank lines. So where are these blank lines coming from? Well, you may remember that print introduces a new line no matter what. And the other thing is that when we, again, if we were to print this file out, you can see that there are new lines in this file as well. There's a new line at the end of David, at the end of say, at the end of that. Of course, you can't actually see the new line, but because the file is dropping down and jumping to the left, because the screen does that, we know that the new line character is there. It wouldn't be doing that otherwise. And we also know, and I'm telling you now, that text files are strings of text that are separated by new lines. The new lines mean this is a new line, so please drop down and go to the left. And that's why the screen displays it this way. It would be possible to display the file with the new line characters, and then it would be one long jumbly stream that would be hard to read. But when we print it to a screen, the screen sees the new line character and drops down. So this is what tells us that the new line character is there at the end of each line. And if print introduces a new line character and the line itself already has a new line character, then we're likely, and then it's obviously clear, why we have what seems to be an extra blank line. In fact, it is an extra blank line, and it's been introduced by print. If we were to put a comma after it, that changes the print statement considerably. The print statement then appends a simple space to the line. That would be invisible to us, and if we were to run the program again, you could see the lines are now printed with no new line. There's certainly nothing to worry about, but one other thing we could do if we were concerned about it is we could strip the line. We didn't talk about this very much at all, but if you look into the directory for strings, there is a method called rstrip. Rstrip takes away any white space that's at the right end of the line, and new line qualifies as white space. So if we want to print it now and get new lines, we'll do a normal print without the comma. We've stripped out the new lines, and if we run it again, you'll see, oh, it did not work. Why didn't it work? Oh, I know why. Because strings are immutable. Sometimes the simplest things are easy to forget. Fileline equals fileline.rstrip. So .rstrip returns a new stripped line. And if we print it now, we'll see the lines with no extra blank line because we've stripped the new line from the string. And now we've printed it with no comma. That is, print statement will add a line automatically. If we were to do both, strip it from the file and then place a comma after the print statement, you can see it runs the entire text together as if it were one big sentence, which could be very useful. It really depends on what you want to do. So that's looping through a file, and that's basically how we do it. Later, we're going to look at an additional argument to open that lets us write to a file, but we're not going to do that yet. One thing I would like to show you, though, is a standard idiom that makes things a lot clearer and simpler and saves us a line of typing. Instead of assigning the call to open to a file handle and then looping through the file handle, we'll simply conflate the two and say for file line and open test.txt. It's doing the exact same thing. It's opening the file, returning a file handle, and then we're looping through it. But instead of creating a label to hold that file handle or to be associated with that file handle, we simply place it where it needs to be, where we would have put the label, and it'll work the way we expect. It'll loop through that file handle. Now what's interesting is that the file handle has no label. There's no label there, right? So it never gets assigned to anything. And in fact, it's going to hang around until the point when we close the program. So sometimes that's not necessarily what people want or what everyone wants, but it does serve our purposes. And for the most part, we don't really care about an open file handle hanging around. That would be a much more advanced concern that would come into play if you were writing a program that runs for a long time, like a couple of weeks or something like that, and it might be continually creating new file handles and would eventually maybe overwhelm the memory. But for most scripts that we create, we don't care because the script is going to end soon enough, and when it does, the file handle will be destroyed as everything else is. But that's getting ahead of ourselves a little bit. The only thing to take away, as they say, from this particular YouTube video is the way that we open up the file and loop through it. One question I'm going to ask you, excuse me, I'm about to sneeze and not edit it. Refreshing. One thing I'd like to ask you is, what sort of object is file line? If we said var equals file line, what type of object is that? It's not immediately apparent. There is one way to test, of course. We can check the type by simply wrapping it in type. It's type string. So we know for a fact all the way going forward, anytime we run into this situation again, that the file is text, and that when we open it and read it, each line of the file is going to be a string. So let me ask you this. If we had, let's say, a group of numbers, 1, 2, 3, 4, 5, maybe we would like to print the number alongside another string. So we could say let's just say for num in open test.txt, print line num. That'll work perfectly. But maybe not so perfectly. Why are we getting line 1 and then it's dropping down to give us the colon? As you can see, it's saying line, and then it's concatenating num, and then we're giving the colon. Why do we have that extra new line? Well, it's for the reason that we just discussed, that every text file has new lines at the end of each line. So again, we're going to need to strip it. Num equals num.rstrip. Or we could go even further. Why don't we just take this part out? We could go even further. Oh, interesting. Why does it say line at the end? Let's look at test.txt again. Oh, there's an extra line. Okay, let's take that out. Okay, that's working. We're concatenating one string to another, which works great, and we're also saying num equals num.rstrip in order to get rid of that extra new line. Another thing we could do is put these two together. And why don't we restore what we had before so that we can see that the colon doesn't drop down. Okay, that works. Interestingly, num.rstrip, which, as you know, most string objects will return a new string. That is the string mutator, the string methods that change a string. When they're called, they return a new string. So you can see that what we're doing is concatenating one string to the return value of rstrip, which is, of course, a string, and then concatenating that to a colon. But what if we wanted to work with this number in math? Let's say we had a sum, and we wanted to add whatever the number is, create some sort of Fibonacci. Let's again look at test.txt. You can see that test.txt has 1, 2, 3, 4, 5. So maybe we want to add up all these numbers. Is this going to work? Is this going to work? Let's try it. Well, no, it didn't work. What did it say? Unsupported operand types for plus, int, and stir. It's the old problem. we wanted to treat these numbers as numbers, but since they're coming from a text file, they're strings. So that's not going to work. Instead, we would need to integerize the number, and then it should work. Well, I added it up and didn't report, so let's print, whoops, print the sum is sum. What's wrong with this picture? Well, you can't concatenate an int in a string, so we're going to have to stringify sum. The sum is 15. So adding up 1 through 5, you get 15. Okay. The last thing I wanted to do, and I don't think it's going to work, but it's just something I'd like to experiment with, so let's see if it would be interesting for you. File handle equals open test.text. The thing is, you know we can loop through file handle, right? We can say for line in file handle, print line. My question is, if you can loop through this object, could you take a subscript of it? What if we're interested in the first line of the file? Could you do this? I tend to doubt it, but it does make me wonder because it is an iterable. It is an iterable, so we can iterate through it. If we can iterate through it, could we possibly take a subscript of it? Let's see. Okay, that didn't work. Let's take out the colon. File object is unsubscriptable. Okay, it didn't work. My guess was that it wouldn't work because generally we go through a file and then we would need to close it in order to loop through it again. Which brings me to the way that we close file handles. We use the close method on the file handle. So this is us looping through a file through the file handle and then calling close on the file handle in order to close the file, which simply means that we've released any sort of resources that the operating system is holding for us when we opened the file. So there it is, printing each line of the file plus the new line, and here's us printing it as is, straight out of the file. So cheers. Always let me know if you have your questions, and good luck with the homework.